Welcome all. Welcome back from our bit of summer break. Welcome to the September edition of the Passive House Alberta Coffee Talk. My name's Frank Crawford. I'm the Education Committee Lead with Passive House Alberta. And today we'll be hearing from Jeevan Thaker. He is the President and Sales Manager at HVAC Systems and Solutions. And he will be discussing the Lunos centralized or ductless ERV system. So I won't take up any more time. So Jeevan, take it away.
Thank you, Frank. Thanks for the introduction. Really appreciate it. Happy September. Back to school, back to work. So thank you very much. Really appreciate the opportunity. Hope everybody has a little sandwich, a little bit of coffee, drink, and ready to go. My goal here is to talk about a Lunos product that we represent, but we'll also talk about the application, lessons learned, and some of the installations we have in Western Canada. I'm going to just take my camera off just for bandwidth's sake, and then I will put my camera back on for questions. Quick little introduction about HVAC systems. I won't bore you, but we are serving our 23rd year. Our head office is in Vancouver, British Columbia. We've got 4 offices there: Vancouver Island, Lower Mainland, obviously BC Interior, and then Northern Alberta. In 2019, we opened an office in Alberta. We have Christina, who is in the Edmonton office, and Rodney, who's joining us today, also in the Edmonton office, serving all of Alberta and Calgary as well. A little bit about us: we're in the commercial, institutional, multifamily, healthcare, industrial. We're going to focus on this, but in the last 5 to 7 years, really into the zero emissions and passive house, multifamily, residential, and commercial projects. If you go to our website, we do have these sections on our website. If you hit them, they actually list all the projects that we're working on. So it's kind of a good reference point if you have any questions about the products. And then feature products. I know that Rodney and Christina have already spoken around the Swagon product line, which are ERVs. We call them centralized ERVs. And today, just a few down, we're going to talk about a decentralized mini version of that is the Lunos product line. I won't bore you about our product lines, but we have over 30 product lines now in Alberta. Here's some of them that are listed on our website. Product application projects. Let's start. So how does Lunos work? It's a ductless HRV. So it sounds unique and it's different. So how does it work? So if you think of a pair of speakers where they work in tandem, this is a Lunos system that works in tandem. For example, if you can see my mouse, here's one of the Lunos systems here, and here's another one. We'll just pick on this one, for example. So they work in a pair, like a pair of speakers. Outside air is drawn through the Lunos system, and we'll get into a little bit technical of what the Lunos system looks like. Basically, the air gets drawn in through here, moves all the way across. While the air is coming in here, air is getting exhausted out of this Lunos system. So they work in pairs, and they reverse after 70 seconds. So this one will come bring fresh air in. 70 seconds later, this will push the air out or exhaust the air out of the building or home. This one will do the same. So as this one's bringing in air, this one relieves air out of the building or space, and then 70 seconds later, this will bring air in, and this one will exhaust. Let's talk a few facts about the Lunos system. So what is this thing? And we'll get into a little bit more of how to install it and the applications, but we call it a decentralized compact unit. It's a product that's made out of Germany. Company Lunos has been around for 60 years. And the product has been represented in 36 different countries. We, as HVAC Systems, own the rights of the Lunos product across Canada. We have projects in Montreal, Toronto, and then Alberta and BC, of course, as well. So continuous operation. So HRV is all about bringing fresh air into the space, right? Again, I think I explained it, 70 seconds in, and then it exhausts 70 seconds later. Some of the cool things from the sales point of view: the heat recovery, my core, it's a ceramic core, and I've got better pictures, but that's the core where the outside air will come in, heats up the core, and then brings a warmer air into the space. And then 70 seconds later, it comes from the return air in the space, occupied space, through the core, and then exhausts out. We're achieving, again, brochure, we're achieving 90% heat recovery on this. I'm going to get into more options, but standard, there's a throwaway filter here. We can upgrade these to MERV 8. And just as recently as 2022, this year, we now have a MERV 13 option, and I'll show you that as well, which is kind of cool. Single pass regenerative system, all I'm saying is, again, it goes through one, come, and then 70 seconds later, you'll get the idea of the 7-second reverse cycle. No ductwork, simple design, and it's low voltage. So an advantage to the building, construction of a building. Obviously, there's no ductwork, so there's some labor savings there, but low voltage, which you don't need a full electrician to do the work as well. So that was a good savings on some projects that we've been involved. We've got over 15,000 units installed in BC and over 1,500 units operation in Alberta. I didn't list Toronto or Montreal. That's the East Coast, we're West Coast. Before we get into the application, it's just good to kind of understand when we brought the product line over. It's been about 5 years now.
Yeah, I think it's about 5 to 7 years almost now.
One of the first challenges we had was obviously have certification in Canada and in North America in general. So we had to go through some third-party testing. Met Labs Laboratories was we worked with in conjunction with CRN Canada, and we achieved our CSA approval for these units. So that was the one testing we did. The second testing in Lunos in Germany, they have their own test lab facility, and we'll get into that a little bit as well. But these are our testing documents. That process probably took us almost 2 years to get it certified for Canada. I jumped ahead a little bit, but test results. So in BC, we have pretty mild climate. The units are working fine. They've been operating for 5-6 years. And then we started expanding our profile into not only just the homes, but into commercial buildings. And one of the first commercial buildings we worked on was with U of A. They were interested in the product, and they were interested in doing a retrofit, and they were interested in just the timing of a project to be completed. But the first hurdle they wanted to make sure was, can these units actually operate in cold climate? Again, I mentioned we have them already operating in Montreal and Toronto, but West Coast, Alberta, we had not. So we did some third-party testing as well. This is a good report. 2 things the engineer, the energy consultant, and the U of A wanted was operate at -25°C, and do they operate at -33°C? So those were the 2 tests that were done. One was done in Germany at the Lunos factory, and then one was done actually on site with an independent contractor. Both times they did achieve those temperatures. They do work. I think one of our key things, and keep in mind, this is a continuous operation ERV, meaning it's always operating, right? It's 12 volts, not taking a lot of power. If you stopped a conventional HRV and then restart it, you get into defrost mode. You'd have some issues with cold climate. With us, I'll get into a little bit about how we programmed it for cold climate. And cool thing is, hey, we're heating up the core, we're exhausting out of the core. We really don't have defrost mode. And we're also talking about a smaller CFM. When we did do these tests, they wanted to know what the efficiency was. Earlier in the slide, I mentioned 90% is our brochure number, and that's, pretty temperate climate. At -33, we're achieving 82% efficiency. So we went from 90, let's call it at 0 degrees. At -33, we're 82. We might be even higher. Might be as high as 85. But there was some degrade in definitely with the efficiency. But everyone thought that on the team we thought it was acceptable temperatures for sure, and efficiencies. I spent a little bit extra time on that, but I think it's important to kind of go through just the procedure of how we develop the product. Let's keep going. Just some features, right? So we have an E2 short. This is stuff that we know, but then E2 standard, basically, I think people like to know what's the length of the wall or the thickness of the wall that you would need. Our majority, I would say 90% of our business is in the E2 short, a 7-inch wall. I'll show you how we install that in the unit, in a wall. I'll show you that cabinet. But some walls in passive house, especially, there's larger, thicker walls, building envelopes, a key part of it. So we sometimes go with the E2 standard as well. Again, just some small information. They're 6-inch diameter units. And obviously there's a transformer from 120 to 12 volts, and that's our efficiencies. So just a quick little slide. This consultants, we help with mechanical engineers and developers and architects on just again, an overview, a rule of thumb. Every project, please contact Christina, Rodney. We'll be happy to lay out the Luno systems, but it's a good metric to just kind of give an idea how many pairs you actually need for a 2-bedroom townhouse, for example, or a 3-bedroom. We have done unique designs where a 3-bedroom, instead of having 2 pairs, so 4 units, we've gone with 3 units, but it depends on the layout. But it kind of gives you a good space, right? So this is for an apartment building, homes, it's a good place as well. I'm kind of going at a good pace here. So we'll talk about a couple of projects where they just want more out of the product, meaning instead of going into your suite, you hit a button and you have the Luno system already operating. You can have it in different modes. This is particularly for a DDC building. We can do normal mode, we can do optimized mode, we can do night mode, we do morning warm-up mode, we do purge. And this is all a pre-programmed DDC plug and play. I'm going to get into it once I get into the actual application and project, and I'll dive into it a little bit. DDC controls, just we lay this whole thing out. This is again for a U of A project. They wanted to tie it into a front end DDC, and I'll explain that a little bit more, but this is kind of what it looks like. New product. So 2022, I mentioned, I think this is kind of a game changer for us. A lot of our consultants and users that have been using the Lunos product line for the last few years, 7 years, they want more. How much more CFM can we use? Can we push this to a bigger, instead of having 4 units in a suite, can we have 2 units? So the great thing is Lunos is always developing a product line. We have a new product called a model E260 is what it's called, and it's almost double the CFM. So we were typically for a pair about 22 CFM. We're actually about 35 to 40 CFM for a pair of Luno systems. So significantly larger capacity, but not larger in diameter, same diameter of the unit. It's just better fans that we're using, more horsepower. So more CFM, lower consumption of just more efficient core, and then more intelligent controls is what the other generation of product is what people are asking for. What does that mean? Well, I'll show you. So people are getting fancier, right? They got used to the product now. It's been in the industry for a while. What else can we do? Well, here's your standard hoods. So picture this outside of your wall on your home or apartment building, multifamily. And it looks like most people call it like a dryer bit. It does look like that. There's different versions, different colors. They can come unpainted, but some fancier buildings, I would say, we have a different version called a facade element, where this would sit inside the facade on the outside of the building. Then the facade would actually fill it. And now you have this little grill that's only staying out. So it's more of an aesthetic thing, but there are different options now as the product is evolving for North America. I put the smart controller. I think I mentioned when you go full DDC, you can do a lot of different features. Well, now we're trying to implement that into a simple residential home with smart controllers, night setback, meaning just quiet mode or different modes. This is kind of a cool game changer for us. So a lot of feedback was, can we get better filtration? Well, when you get better filtration, you're going to have more static pressure. You have to have a fan that can handle that extra additional static pressure. But first thing is, can we actually do better filtration from outside air? And the answer is yes. So we do have this product now. It is a MERV 13 filter. As you can see here, this is your standard, which is that throwaway filter. And as you go to a sound insulation type of screen, this is not for sound for the Luno system, from the outdoor, not ambient sound. So cars, street noise. And then we call it, and if you can see, it's a lot thicker of a casing, so we can slide in our thicker filters. So really cool. I think that's a game changer for this year and moving forward. I think most of our projects are going to have MERV 13 filters, either the sound one or just a better filter. I think this is going to be interesting. So as we were working through some of our high performance buildings in British Columbia, we are again with our product with Swagon product. They came and approached us, Passive House approached us and said, what about your Lunos product? Can you get Passive House certified with that? That's a process. And I mentioned that earlier. We're in the process of that. I'm not sure how long that process is going to take. It may take a year or two. We're already into it for a year. There's just a big backlog of products that are trying to get through Passive House and certification. But what we ended up doing, working with the local energy modeler, and if you see this air tightness place, so what we do is provide for a building envelope that's a tighter building envelope. We provide these flanges for a tighter fit in a building. So super cool. And we've been successful doing that and helped out with the building envelope leakage rate. Here's a great one. This is actually from our Montreal project. This was a concrete, there's a wood one and there's a concrete masonry building. These are just details that we work with, again, the architects, the building envelope people. As you can see, with those flanges, we can tighten up the building envelope. So kind of cool. Then we do these details for, we're working on another one that's not up here because it's in process, is with a window supplier. We're going to try to do a window, full window with a Lunos penetration through that. And as soon as we have that, we'll be happy to share that with everyone. That was our next request from someone that was working on our project. So when we brought the product, of course, we are in the business of new construction. We promoted it with engineers. We got it designed, we got it certified, and we sold the project, got it installed, and everybody's happy. Over the last 3 to 4 years, our biggest part of the business is actually retrofits for homes, townhomes, and high-rise buildings. And I'll show you a couple of projects that we've been doing on retrofits. So I know these are just renderings, for example. The first maybe 4 stories of this building would be all Lunos, and then the above would be a Swagon HRV package unit. So a lot of hybrid type of applications. For example, you'd have your HRV in the attic space, and then maybe Lunos in the basement, for example. So lots of creative ways. One is to cut costs, one is to keep the energy numbers up. And yeah, those are kind of your 2 big things. This is our Lister redevelopment, Mackenzie Hall. That was our first building of 3 buildings. One of the challenges was U of A had 3 buildings, and a conventional way would have been, and this is a retrofit, would have been take all the students out of the building, try to do this work in the summertime when they're not there, and then get your electrical contractor on board, your general contractor, your sheet metal contractor, mechanical contractor. And they had those 3 buildings slated for 6+ years to do the retrofit for those 3 buildings. Then they researched, they found us on the internet, they contacted the engineer reached us. We sat down, had a meeting with them and said, hey, there's a product that we have. Are you interested in looking at this? And I always put just the construction time. So there was 363 suites, so we had quite a few units, right? Times that by 2, so that's 700 units or so. Construction time was Q4 when they gave us the go-ahead. Equipment arrived Q1 of 2020. I think you can't see that. And we were commissioning the whole building in Q2 2020. So pretty quick turnaround, right? So no electrician on board. We had the controls contractor doing the commissioning. We pre-programmed the whole building before it shipped to site. No duct work. So we sped that up. And because of that process, we've now completed all 3 buildings. I think all 3 got done within 2.5 years. So we saved the university almost 5 years of construction, not to mention how much cost we saved them, right? So take advantage. Here's a little bit about that project itself. A couple of things, just details. If someone's going to be very detailed and ask questions, we slope these units. So during the cold temperatures, if there is condensation, we have no drip pad, no condensate trap. It just slopes out that way. Here's our louver. Again, what we supplied on that project was 2 Lunos per suite. I'll show you a picture of them. The sleeves, the actual sleeves that come with the unit. We provided a wind baffle. I'll show you an example of that. Interior grill, filter, transformer, and the J-box was by the local DDC controls contractor. Here was the schedule that the engineer ended up putting together that went out for tender. So that was a typical suite in Lister. And again, every project's different. The university decided they wanted a clean finish. Maybe it's students, I'm not sure. Maybe it's a safety thing. They ended up putting a bulkhead here. So they replaced all the windows, put a bulkhead in here, and it's hard to see, but here's our 2 Lunos systems. There's a better picture. They put the sleeves in. So one of the cool things about construction was the general contractor ended up coring the holes for the building. They had the sleeves. We shipped them earlier. So all this work was done prior to the units, the Lunos units being commissioned or installed. This is pretty fancy. They put this all in conduit. Again, it's a university with the junction box there. Doesn't have to be, but they chose to do that. So that's a finished picture. They finished the bulkhead, and that's their suite. And here's a pair of Lunos just on a finished product in this common area. Henday, I think that's our last one, our 3rd one, which is getting completed. I think it is completed or commissioned by, I think we're trying to get it done by the end of October. So that would be our last one. I mentioned a baffle. So here's your little system. We put a baffle in here. A couple of reasons why we did that. One, we weren't sure of the wind direction, the driving wind in a different area, the way the buildings were configured. The other factor was as the buildings get taller, anything above what Lunos came back was anything above 6 stories, they would recommend putting a baffle in front of the actual Lunos system. The main reason, just so we can have straighter air coming into the Lunos. So as it's exhausting, this flap actually flaps over. The Lunos, when it switches from 70 seconds, comes out, and then they'll flap back, and then the air gets pulled in. But it's a mechanism to straighten the air to maximize the efficiency through it. Because 10 stories up, the wind is just kind of swirling or doing things differently than at ground level. So we do that, and that's standard for us. Anything out on a building that's probably 6 stories and above. This is another project, Walton Towers. This is out in British Columbia. The owner phoned us, found us out, wanted to know if it worked, phoned U of A. Obviously for residential, it's a lot simpler system, but the cool thing about this project was the owner ended up subsidizing the occupants. So for example, and this was not us doing this, but they said, bring the Lunos system per floor. So there was one floor that all the occupants rented out into a hotel for a few weeks. They put the Lunos system in, they came back, and he just did floor by floor by floor by floor, which was super cool. So he had the building occupied while they were doing the retrofit. These blue things are totally outside of our scope, which is just the building envelope, but they wanted to bring HRV or heat recovery and fresh air into his existing building. The same owner is now doing 5 more buildings with us this way. So he had no downtime from all his occupants as they were doing floor by floor. So small, not too large of a building, but 48 suites, 8-story building. So pretty cool. I always like showing the engineers layout. So working with the engineer here locally, they would list where they wanted it. The architect would obviously want to move it somewhere else. We send this actually in-house. We do this here, Luno, and we send it to Germany just to verify if the locations work. Key things are, how's that air going to move into the suite? So you always want to have it 90 degrees, but we look at that kind of stuff and we'll review it for you. But that's the layout for Walton Towers per floor. This is one of my site guys, and it's a site service person that came out and took a picture. Here's some worldwide projects that are used for Lunos. Obviously, these are I believe, in Germany. Again, I think I mentioned 39 countries. Just a quick summary. This is just our white paper. We call it just a summary, a quick glossy, just kind of understand what we've done and the progression of the E2 and E260. Most of it I've already talked about. Here's that air tightness that everybody's really excited about. And the filtration, I think, is a big key thing. And the third thing was the newer unit with more CFM controls. Depending on the building, depending on the occupant's requirement, we can do full DDC and tie into DDC systems, which is kind of cool. CO2, temperature control. There's some cool things that we can do.
Good. So yeah, excellent. Thank you.
You're welcome.
So 1 or 2 questions. So I guess maybe coming back to maybe a single house or residential. Sure. Does the Lunos have a way to do kind of kitchen exhaust and bathroom boost modes, or do you generally separate that function, I guess?
Yeah, great question. Kitchen exhaust, definitely by code, you need to do a separate way to do that. So you take that out of it. Bathroom exhaust, we are working on a control system. I was showing everyone the smart controller. There is an idea, and in Europe, they are using the same controller. So we now have that available in 2022. But what would we do? Just an idea, and we're designing it right now with an engineering firm here and locally, is a design where we'd have a pair of Lunos in your space for a home. You'd replace your bathroom exhaust with a Lunos unit. So your bathroom exhaust fan is going to continuously run, tie into this controller.
So you just kind of add a third so that maybe 2 of them are exhausting and one's
bingo. Yep.
Bringing in. Okay.
Yep. And so we're going to have a sequence of operations. We're going to have our first install in 4th quarter of this year. And then we'll probably start kind of marketing that. That is another request that everybody's having. Yes.
Sometimes when you're in the bathroom, you want to get the smells and the contaminants out quicker. So
yeah, and I think everybody's trying to get to just having those continuously running, especially they're so quiet. Out of the box, I didn't mention, but Lunos is about 26 dBA to 30 dBA or something like that. So it's quite quiet compared to your conventional bathroom exhaust fans.
Yeah, definitely. So you did mention that it is an ERV. So
yes,
most people know, but maybe explain the difference between ERV and HRV and how you get the moisture out of it and how that works, I guess.
Yeah, great question. And so HRV, so heat recovery ventilator. Heat recovery ventilator is taking the sensible, which is like, so picture people in a space is the best way I can describe it. That moisture in the space from people, you need to remove that. If you have a shower in your bathroom and you have condensation, you need to be able to remove that. So an HRV unit cannot do that. An ERV unit can do that. And it's a coating basically on your ceramic wheel. In larger units, it's a coating that they put on the actual heat exchanger that allows it to do that. So it takes the droplets out of it and out of the moisture out of the air and transfers out. Where an HRV will not transfer the moisture out of your building. I'm just thinking out loud for Alberta, right? So maybe people think, well, once it's cold, it's super dry, but you always have moisture. You always want to be removing some kind of moisture. You're always going to have too much moisture in a space. You're never going to have a dry space. Unless you're leaving your window open all night, you might get a dry space. But generally speaking, you would want an ERV in a home for sure, and especially in like a U of A, for example. That was a key criteria that they wanted. And our units are standard ERVs.
Yeah, having the moisture recovery, especially in Alberta, which is very dry, to help maintain that higher moisture inside in the winter and not dry out the space. Yeah.
Bingo. Yeah. Yep. You bet. Great question.
But yeah, but it won't let you go too high. It works just on diffusion or difference in moisture. Wherever there's more moisture, it will move the moisture there.
So. Yeah. So for homes, right? So outside of a bathroom, you leave the bathroom door open, it's going to try to pull that air right out more. But again, I think people just for the first time, if you're hearing what a Luno system is, the unique part of this, and it took us, 7 years to kind of understand the marketplace and convince the marketplace. But when you have continuous moving air, it's just always running, right? So you're always getting fresh air in your space. Where you have a commercial building, your office space that everybody's in, you'll hear a compressor run on your rooftop unit, or you'll hear a fan running. They kind of hit a set point, then they stop, right? Then they hit a set point in temperature or CO2, they'll start and stop. With the Luno system, the best way I can explain it is it's like walking outside in your home. We have over 15,000 units in residential. Every testimony we get back is, yeah, my basement smells like I'm outside in my backyard. It's just that constant air moving all year, 24/7, right? Pretty cool.
Arnie had a question. Is there kind of a square footage per set, or is it kind of the occupancy per set? How do you kind of size how many you need, I guess?
The game changer is the new E260. Again, 90% of our projects are going to be the E260. Everybody in North America wants more air. We just are different than Europe. So that's a good thing. So that eliminates the number of units. So number one is there's a square footage of, depending on the CFM, and also the layout of the building. So I think I gave a guide there. For a studio, it'd be 1 pair. For a 3-bedroom, might be 2 pairs, so 4 units in your suite. It really depends on the layout. We always want to be our hands-on on the applications. But 40 CFM, you're going to get away with, if someone had to press me on that, you're good for 1,000 square foot. Maybe pushing it a little bit more. I don't know. It depends on if it's an open plan, if you got a bedroom. It depends, right? It depends where you locate it.
That's why they have you guys to help the design.
Yeah. Of course, let's get an engineer on board, make sure they're the right people to have to sign off on it. But then we would get obviously Germany and us to look at it, like this one. That's why I'm sharing that screen. For example, the engineer had one in here and blowing this way. So picture this one right here and here. So we thought that was a bad idea because now you're bringing in air here, you're exhausting here, but you're not mixing all that air. So now, if you notice, the air is kind of coming back and getting pulled, right? So most of this area is getting pulled. So it's just placement of the unit.
Another question, since you're having always in pairs or multiples of them, is it a direct hardwire connection or can it be a Wi-Fi connection? I'm just thinking maybe even for retrofits, it's nice not to have to run ducts everywhere, but do you still have to find a way to get a wire between all the units?
Yeah, so the current answer is yes, low voltage wiring. So poke a little hole, throw it up in your attic if it's a home and down. It's very simple. Even I've been able to do it myself, which is a big feat, but that's the answer. The next answer is if you go with the Luxon DDC system, one of the things that the U of A is looking at is Wi-Fi instead of wire, and we do have that option, but it's more of a full DDC system, and it's a cost thing, right? You're going to want to run wire, then go full DDC, and so it depends on the building. but that option is available at a larger scale, is what I'd answer.
Another question, I guess, if it ever breaks or if we need service, do we need to get to the outside or is it all service from the inside?
Yeah, great question. This is the outside, right? Outside of the building, on the other side of that window. You put the sleeve in, the unit gets slid in from the inside, always the inside. So this cover comes off. And on the back side of this, there's a little handle, like a little, and you pull that out, slide it out. That's how you clean the filter as well. If filter comes out that way. And if you needed to clean the core, yep. And the fan. So this whole assembly comes out as one. We don't want occupants hanging out of a 12-story building and service the unit.
I guess, have you ever put one or ever installed one in like a camper van or a tiny home or a mobile home?
So Tidy Home is just featuring, they're just launching their new marketing. Yes, we are working with tiny homes exclusively on their projects right now. In fact, in my email, they just asked us to support them on their marketing campaign. So yeah, we've got quite a few tiny homes.
No camper vans yet?
No, not enough time. But yes, we need to Rodney. We need to keep Rodney busy. That's his next plan. Thanks, Frank. Thanks for keeping him busy.
Yep.
Someone give me a van.
Yeah. Deirdre's asking, so I guess have these been used in residential retrofits, or kind of what would be the application for a residential retrofit that where you might have the furnace already, but
Yeah.
you could use these?
So for homes, of course, it's taken off quite a bit. So first place where I think people identify where they need more air. So you have a furnace in the house, that's great, but your basement's kind of really muggy. So people just get a pair from us and they put them on either side of the building of the house. And within 2 days, to be safe, but 2 days, you'll come downstairs again and that air is just fresh and clean. So people do that. Just with the warm air, if you have a 3-story house, the upstairs is typically quite warm, right? Unless you have a AC, but people put them on upstairs as well, just in the bedroom area, just to make sure we get some outside air circulating in the upstairs. So yeah, retrofit. Again, the great thing is you don't need ductwork, right?
So yeah, if you put an addition to your house that doesn't have very good airflow, you could use these to add the air into that.
Yeah.
If your fully ducted furnace is going everywhere, then probably a centralized HRV system would make more sense there. But
for sure. Yeah. And then
but
our swing on unit would fit in the attic space and duct it and tie it in. Sure, go for it. It's a cost thing, right? So if it's a new building, you'd probably design it with our swing on HRV or ERV, but retrofits, first cost, and we stock quite a few of these in BC, right? So that's also a very handy thing where, if you're buying an ERV these days, even residential type, I mean, you're waiting 10, 12 weeks, right? So nice to have these things stocked in BC.
So you guys haven't hit your the supply issues as of yet?
We haven't, no, we've been, we have, just to give you an idea, we have probably over 500 units stocked in, so units are a pair, right? So that's quite a few.
Nice, excellent. Yeah, and Rodney mentions that, it'd be probably good use for if you're making a secondary suite or a garden suite or turning your garage into a workshop. It's a good way to add airflow in there.
By far the residential side of our business. That's number one use of Lunos, is turning the garage into a suite upstairs, and that's what they're doing, is putting a pair of Lunos up there.
Yeah, it's definitely a good option, because if you're spending a lot of time in that garage, especially if you're tinkering with your car, you might want some fresh air in there.
Yeah, exactly. Yeah, I like how you think.
Yes, I guess maybe for some of the overheating is with the kind of the basic controls. Could you just put it as to like a nighttime purge mode or a nighttime where you're always just moving it one way to bring in the fresh air or cool air?
So yeah, so after our first building with Mackenzie Hall at U of A, what we quickly realized is, wouldn't it be nice? So, and this is unique to every project, but again, they went with the DDC because they wanted to be able to check on their apps. The maintenance people wanted to see what units were running, so you could do a lot of crazy stuff, right? You could see people on their apps. But one of the things they said was, well, we noticed the students are all the students are out of the building at 10 a.m. because they're in school, and they're all back at 2 or 3. Hey, it'd be great if we could just flush the building out one way. So they just turned, let's just say, the east side of the wing of a building and had the units pull the outside air in, and the other side of the building, because you want equal pressurization for your building, and they just exhaust out, and they just did that for 20 minutes, an hour. And what they noticed was the air in the whole dorm itself, like all the levels were just a lot more fresher and cleaner. And that costed nothing. That was just part of the program, which is kind of cool, right? Again, this is larger scale. We have 700 units in one building, and we have 3 buildings, right? So that was one. The other one was, even though these things are really quiet, and I think they're quiet, but some people are just not used to having sound or just fan noise running in while they're sleeping. So some students said, wouldn't it be cool if, or the university came back and said, do you have a night mode? Because, we don't need to be pushing all this extra air all night. So we reduced the speed by half, for example, in night mode from, I think it was 11 p.m. to 4 in the morning, just like that. So we did that remotely. We could dial in. And so, things like that were really cool options that the U of A obviously were happy about. So
Yeah, because I guess if it was in a workshop that wasn't used all the time, if you did turn it off, then it would kind of be 2 holes in the building. But you could, put it back to a night mode, so it's just run slowly, so you reduce your heat loss.
Yeah, and to scale it way back down to like a garage, you can, instead of buying the smart controller, you can buy, we call it a manual controller. First cost is cheaper as well, but basically think about it, it's 2 light switches, and the one light switch is low speed and the other one is high speed. That's what your basic package would be. It would come with 2 sleeves, 2 lunos, and 2 light switches basically, and they wire that together. And then low speed is 1 light switch on, second light switch on is high speed. So you can just do it that way, and that's as basic as an option you can get.
And I guess I know it changes by quantity, but do you guys, what's the kind of rough pricing on a pair of these units?
I knew that was coming up. I hate giving budgets. The only reason, here's why, and I'll give you the answer, but just with the industry fluctuating, the cost, materials, our biggest challenge right now is overseas freight, right? It goes from, it doubles to triples, and then it's back to normal. So those things impact the cost. That's why we do have a lot of stock here. But I would say your basic is, you're probably going to be 1,500 to 2,000 for a pair of lunos, sleeve, and your manual switch.
Everything's been going through pretty big price swings, like lumber's changing 300 or 400% every week.
Yeah.
So
Honestly, the cost is pretty good with the product, but it's the overseas freight is unbelievable, unpredictable. Yeah, I just want to say thank you for everyone for listening over their lunch hour, and hopefully it was informative. And we at HVAC Systems love bringing innovative products to North America, to Canada. Thanks for listening.
Thank you all for coming. Thank you HVAC Systems for being a sponsor of Passive House Alberta. I guess I have to do the prerequisite that Passive House Alberta does kind of survive on sponsors and memberships. So please look at the possibly becoming a member. It's a pretty low price, but it helps us kind of do all the work we do and help look around and get some more information for the industry. And with that, thank you. And we'll see you next month